Welcome friends, welcome back to our YouTube channel Crystal Learning. So today the subject is basic thermodynamics, and in that a very good question we will take today, very means conceptual question, and there is lot of debate that what is the correct answer in that, and that debate is because in a book different answer is given, in competitive examination different answer is given, and the right and conceptual answer is different from both of the two, that is book and the answer given in competitive examination answer key. So let's see the question. Two blocks which are at different state, just note down each and every point. That is, it is saying different states, means that temperature will be different, are brought in contact with each other, allowed to reach a final state of thermal equilibrium. Next important point, thermal equilibrium. Then it is saying the final temperature attained is specified by. What will be the final temperature you have to get? So in the book, in a very famous author book, answer is given as zeroth law of thermodynamics. Why? Because it is saying thermal equilibrium. Just you read thermal equilibrium and you know thermal equilibrium is zeroth law. But you just study what is zeroth law. Zeroth law is saying if body A is in thermal equilibrium with body B, and if body A is also thermal equilibrium with body C, then B and C will be in thermal equilibrium. This is zeroth law. But here only two bodies are brought into contact. So this sentence you are saying that A and B is in thermal equilibrium. So how it achieves that thermal equilibrium? It is not saying. This zeroth law is assuming that it is in thermal equilibrium. Okay, that means temperature will be equal. It is assuming for that it is true. Okay, but how it achieved that condition of thermal equilibrium? Just note down the two words that it is saying about only thermal equilibrium, nothing else, zeroth law. But I am talking about condition of thermal equilibrium. That what will be the condition? I am again emphasizing on the word condition, and how it reached that thermal equilibrium. One it is you are just saying that you reach thermal equilibrium. Now you are dealing with the concept. Okay, that is another point. But how you reach that thermal equilibrium? First question must be asked that how you reach that thermal equilibrium. That is not told by zeroth law of thermodynamics. That how is reached that thermal equilibrium. It is just saying that it is in thermal equilibrium. It is in three bodies. So here only two bodies is there. So that option is wrong. That is zeroth law of thermodynamics, and that arises because you just read this part, thermal equilibrium. So now we have just seen that zeroth law will be not the answer. Now next come the point, that is it is given by maximum number of previous year that books by coachings, and you answer key from different examinations also. You see it is given as first law of thermodynamics. How it is given, I will discuss that first, that why it is given. So for that a small problem is taken, that is aluminum block 1 kg mass 25 degree centigrade specific heat, and another is copper block 1 kg 500 degree centigrade. So copper block is at high temperature, that is hotter with a specific heat. Assume that blocks are perfectly thermally insulated. We have thermally insulated the block, only one side, one face is in contact on which the heat transfer will take place. Okay, so from first law of thermodynamics, dq equal to du plus, if you will take of complete system, that thermally insulated container, that dq equal to 0, work done will be 0, so internal energy will be constant, u2 minus u1, final internal energy equal to initial internal energy. So here we see, that is in the start letter start, we see that from conservation of energy, u aluminum plus u copper equal to constant, or conservation of energy from delta change of aluminum must be minus times of delta u of copper. Why this minus sign? Because that heat energy gained by aluminum block must be equal to heat energy lost by copper block from first law of thermodynamics. So we have written this formula: mass of aluminum, copper of aluminum, delta U of aluminum minus mass of copper, C of copper, and delta U of copper. So we have put the formula. If you just closely just see this relation, here let's find out what are the knowns and unknowns. Mass of aluminum given, copper of aluminum given, T initial of aluminum given, mass of copper, C of copper, then T initial of copper is given. If we talk about two unknown, that is T final of copper and T final of aluminum, it is not given, but you say these temperatures will be equal, and let's assume that T, and we give the formula. But how we are saying that when the heat transfer will occur, the temperature attained will be same for both the system. This point is not told by or explained by this first law. First law only tells about conservation of energy, that energy will conserve, energy will conserve. It is not saying that T final equal to this T final temperature of aluminum. From this equation 1, we can't say any relation also, because we know here two unknowns. In basic math we have studied that to solve two unknown or two variables we need two equations also, but here only one equation, so we can't solve this relation. Okay, we need a second relation, having discussing the relation between the final temperature of aluminum and copper. If any equation gives the relation, that relation we can use here and we can find the temperature of this unknown, two unknown. So it is clear that why first law will be not there, because every time our intuition says that final temperature will be same, but why that final temperature will be same, nobody is discussing about why final temperature is same, why that heat transfer will occur up to that point. Only when final temperature is same, then the heat transfer will stop. So this point is not discussed until now, that is first law of thermodynamics. Okay, so here we see that therefore final temperature attained cannot be specified by first law. We are stuck here because we know up to, if you suppose you give this problem to a person who knows only mathematics, doesn't know, he is very good in math but doesn't know the concept of thermodynamics, what he will say, up to this point three condition can be arise, that final temperature of aluminum may be greater than final temperature of copper, or final temperature of aluminum may be smaller than final temperature of copper, or final temperature of aluminum can be equal to final temperature of copper. Three condition it can be set from this relation. Okay, three conditions. So from these three condition, which condition is true, you cannot tell by first law of thermodynamics. Okay, first law of thermodynamics. So so to tell this, that what will be the final temperature of condition is given by second law of thermodynamics. Right? Now let's read some point that will make clear that this statement. Okay. So in example problem 1, we brought blocks of aluminum and copper in thermal contact at time equal to T equal to 0. The block of copper immediately spontaneously started to transfer heat from hotter copper block to cooler aluminum block, we know. Now we will discuss what is the driving force for this heat flow or transfer to occur. There must be some driving force, because the gradient will be there, then only that transfer will take place. So what is the driving force? So the first law of thermodynamics, that is conservation of energy, cannot be the driving force for energy transfer. Why? Because the total energy of the system remain constant throughout the transfer of energy from copper block to aluminum block. Whatever the conditions or the transfer is there, suppose this is the transfer part from A and transfer part of B, copper and aluminum. So at every point that conserved energy is conserved. So if energy is conserved or constant, so what is the driving force? For any driving force you need a gradient. Okay, you need a gradient, but here you don't find any gradient in energy. Conservation of energy is remaining constant for both of the system, you don't find any gradient. So first law of thermodynamics is not able to explain the heat flow. Okay, we said that the energy or heat transfer was due to Fourier's law. You just study that heat transfer subject, there you read Fourier's law. Heat flow is due to thermal gradient, because here we know there is a thermal gradient, temperature is different of the both system, so there is thermal gradient, which is correct. So here the driving force is thermal gradient given by Fourier's law, and Fourier's law is only a consequence of something more fundamental, that is an alternative statement of second law of thermodynamics. This Fourier's law is an alternative of the second law of thermodynamics, and second law of thermodynamics says spontaneous changes will occur within an isolated system with a time in a direction that tends to increase or maximize entropy. Spontaneous process will occur in that direction only where the entropy is maximized or increase of entropy, which we have studied in entropy. Okay. Therefore, the second law can be considered that the driving force that caused the heat to spontaneously start flowing from hot block to copper block, to from hot block of copper to the cooler block of aluminum when two materials are brought in thermal contact, because this second law is able to tell that from which block that heat transfer will occur because of that thermal gradient, second law. So therefore we know that entropy of the system increases when heat flows from hotter copper to the cooler aluminum block. Okay, that entropy of the complete system will increase. Okay, this is the ultimate driving force of spontaneous heat flow. So this driving force is given by what? Second law of thermodynamics. Okay, so we read here. So again, I am saying this topic. You read in any book, condition of thermal equilibrium. I am saying condition. Very important word is condition, not thermal equilibrium. Condition of thermal equilibrium. In every book, it is written second law of thermodynamics. Okay, condition. You read this condition. I am again saying don't read thermal equilibrium only, condition of thermal equilibrium, because thermal equilibrium is given by zeroth law, but the condition of thermal equilibrium is given by second law. Okay, so let's read. At equilibrium, energy is distributed between two blocks. We know that in equilibrium that energy has to be distributed between two blocks. So in equilibrium, most probable energy distribution, that stable condition is one that maximize the total entropy of the system. That is S total S1 plus S2 of the two objects in thermal contact. So that stable equilibrium or condition will be where we will found it that total entropy of the system will be maximum at that point. So now we will find the condition of maximum entropy. The maximum entropy increase for this system, that is final state of the system, will occur when this maximum entropy will occur when the temperature of the two blocks of metal which reach the same equilibrium condition. Just read this sentence. Where we will get this maximum entropy? Where the temperature will be same equilibrium temperature. Up to that point, heat transfer will occur, and when the temperature will become same, heat transfer will stop because it has reached maximum entropy condition. So these statements are given by second law. Now you know got to know that equilibrium point will be final temperature of aluminum equal to final temperature copper and some equilibrium temperature. So this condition you already know, or there is a intuition, but how this intuition is coming? So that you are putting this T equilibrium temperature in first law and you are getting that equilibrium temperature. From second law only you got this temperature. Okay, so that's why most of the time answer is given first law, but first law is not the answer. In advanced books from the detailed analysis, entropy change and temperature attained of the system can be derived. So this is the graph, and this is known as quanta of energy of the system. It can be studied in the reference book which I will be showing you. Those who are more interested in the going in depth knowledge, but right now we should just see the graph and the explanation. So here you see quanta of energy of system 1 is increasing from 0 to 100 and another system is increasing, because we know one will receive heat and another will lose heat. So that's why in opposite direction. Okay, and we know the thermal equilibrium of complete system S1 equal to S1 plus S2 will be where that it has achieved maximum entropy, maximum point slope will be 0, that is ds1 upon dq1. From this, that it can be proved that temperature T can be defined as 1 by T ds upon dq, and this dq is quanta of energy, not heat. Don't get confused with heat. Okay, and this quanta of energy can be given by change in internal energy. So this relation you can use from second law, that is 1 by T equal to ds entropy change upon d of internal energy, and you can give the formula of final equilibrium temperature from second law itself, that what will be the final temperature. You just know the value of entropy change and internal energy change, and you can give the temperature of this final temperature attained by the system from second law. You don't need the first law to give the temperature attained, that what is the final temperature of the system will be, because we have seen the limitation of first law. From first law we are not able to get this condition that it final temperature equal to final temperature of copper. So from this formula you can get the temperature value from the second law. E inter is the internal energy above the ground state of the system measured in joule, temperature measured in Kelvin, and entropy is measured in joule per Kelvin. So from this discussion we got to know option C is correct, that is final temperature attained is specified by second law of thermodynamics. But if you want to get marks in a competitive examination, always mark that first law of thermodynamics, because most of the answer keys gave first law of thermodynamics. I haven't seen anybody giving second law of thermodynamics, but whenever you get in touch with any learned person or a person who knows basic thermodynamics in deep, so you can discuss this question with them, or you reach IITs, you are in IIT or NIT where good professors are there, so you can discuss these things with your teacher and they will explain the correct answer for this question. For reference point of view, two references are being taken here, that is reliability physics and engineering. Page number is given 348 from Google book. You can read this also. And that second is this Bruce, that matters and interaction. Okay, page number is given. So from these two references, you can read the this concept whichever I have shared. I like to thank these authors who cleared this doubt, and they gave the very beautiful concept explaining each and every detail about this concept, that why second law has to be the answer. So my heartiest thanks to these authors for writing such a good book. I hope your confusion is clear, and now what you have to do in the competitive examination, and suppose it is asked in the interview of ISRO or in some good institution, if this question is asked, then you can explain what is the correct answer, and you can go ahead. I hope you enjoyed this lecture. Meet you in the next lecture with the next concept. Till then, have a nice day.